good. Any point on the line y equals x is of the form.
Ma'am, A is basically X, right?
Yeah, A is the point. See, I'll tell you something. X is a variable. Y is a variable. A is a constant. For example, A can be 2, 2, 4, 4, 3, 3. So that is what, yes, A is X, but over here A is X also and Y also in the first option. So now tell me, any point on the line y equals x is of the
Ma'am,
form?
A, comma
A,
A.
A,
A,
comma A.
A. Very good. Okay. If we multiply or divide both sides of a linear equation with a non-zero number, then the solution of the linear equation changes, remains the same, changes in case of multiplication only or in case of division only. So now just imagine a linear
Changes.
equation, like for example, this one that we had over here, 2x minus 5y equals 7. Okay. Imagine that you multiply or divide both sides of the linear equation with a number which is not zero, let's say with the same number, right? So
The linear equation remains the same.
the solution of this linear equation, they're not asking the linear equation remains the same or not. They are asking the solution of the linear equation remains the same or does it change?
It
Remains the
remains the
same.
same.
Yes, the same. Okay, just a minute. I'm getting this. Okay. Who has joined just now? Abdul Rahman. Okay, fine. Next question. How many linear equations in x and y can be satisfied by x equals 1 and x and y equals 2? How many linear equations can be satisfied by x equals 1 and y equals 2?
One.
Okay. Think about it.
Ma'am, infinite.
Okay. Abdul Jabbar, you said 1, right? Can you give
Ma'am,
me an
1.
example? Preshita, can you give me an example?
Ma'am, for example, x plus y, so 1 plus 2 equals 3. Then we can have 2x plus 3y, so 2 plus 6, 7.
Acha.
Oh, yeah,
Avni, you
many.
said infinitely many. The
Yes,
reason?
ma'am.
It's correct.
Ma'am,
Hmm.
because we can make
You can make
many.
many such combinations. Okay. For example, they're saying how many linear equations can be satisfied by x equals 1 and y equals 2. So, hmm. So here we go. So we have x equals 1 and y equals 2, right? So let's say, like for example, the example that Prishita gave, x plus y equals
Equals
3.
3.
This is a linear equation satisfied by x is 1 and y is 2. Let me give you another example of a linear equation which is satisfied by this. For example, 2 or let's say x plus 2y equals 5. This is another linear equation that is satisfied by by these two variables, by these two values, right? So like this, you can have infinitely many. You can just keep changing the coefficients on the of x and y and the constant term on the right hand side. Is this clear to everyone? Why is it infinitely many?
Yes, ma'am.
Good. All right. Next, the point of the form a comma a. Now this question, Preshita, no, Avni, you will answer. The point of the form a comma a always lies on
On
Look
one
at
minute.
this point very carefully.
Ma'am, D.
D, on the line x plus y equals 0. Acha. So let's say you have a point A comma A. In place of x, put A. In place of y, put A. What will you get?
2A.
A plus A equals 2A. It's not equal to 0.
Yes.
Yeah?
C.
C. Very good. It should be on the line y equals x. A very similar question we had in the, I think it was the third question, right? Third or fourth question. It was just the opposite of this one, or the converse of this one. Okay, clear? Acha, now
Yeah.
Munir. Munir, please unmute, dear. Munir, are you there?
Yes, ma'am. Yes, ma'am.
So question number 8, Munir. The equation of x-axis is of the form
X equals 0.
look at your notes. The equation of x-axis is of the form y equals 0. Okay? Remember, equation of x-axis is y equals 0 and equation of y-axis is x equals 0. So because, just imagine it like this if you want to. X-axis, every single point, that is the x-axis. It is known by the name of x. So x has dominance over there. So it doesn't let y exist on its axis. So y is 0 on the x-axis. And similarly on the y-axis, x is 0. X coordinate of every point on the y-axis is 0. We know that. So the
Yeah.
equation of y-axis is what? Y-axis. X equals 0, right? So equation of y-axis is x equals 0 and equation of x-axis is y equals 0. Okay. All right. Abdul Rahman, please unmute, dear. Yes. This one, the question number 9. The graph of y equals 6 is a line, which of these options? Parallel to x-axis at a distance 6 units from the origin, parallel to y-axis at a distance 6 units from the origin, making an intercept 6 on the x-axis. Intercept means it, for example, this is the y-axis, this is the x-axis. So intercept on the x-axis means this point over here on the x-axis. The point where it crosses the x-axis is 6. That is what the point number C, the option number C is saying. And option number D is saying that making an intercept of 6 on both the axes. That means this is also 6. This point where it cuts the y-axis is also 6. And the point where it cuts the x-axis is also 6. Now, think about this question very carefully. The graph of y equals 6 is a line. Abdul Rahman, this is your question, okay?
Okay.
We have done this question in class. I don't know if you were there or not. Parallel to x-axis or parallel to y-axis or C or D. Okay,
Thing
Abdul,
is, the parallel to the x-axis at a distance of 6 units from the origin.
okay. Everyone else, is this question correct or is this answer correct? Or do you think there will be some other answer to this? I'm asking everyone else. What happened to your videos? Again off. See, it has to be a two-way thing, right? I need to know, when you're sitting in your classroom, your teacher has to be able to look at you. Prishita, you also please. If not in this class, then please from the next class onwards, make arrangements such that you can switch on your camera. Okay. Yes. So anyone else, what will be the answer of this question? The graph of y is equal to 6 is
The A.
A. Okay, everyone agrees on this? A.
Yeah.
Okay. Now, the 10th one, x equals 5, y equals 2 is a solution of which linear equation?
C.
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 C, very good. Okay, if a linear equation has these three solutions, we know that it will have infinitely many solutions, right? So don't get confused. Oh, why does it have three solutions? It can have infinitely many solutions. So just three of those solutions are given over here. If a linear equation has solutions this, and this, then it is of the form
A, ma'am.
A, y minus x is equal to 0.
okay. Abdul Jabbar has given his answer. Avni has given. Others? Abdul Rahman, Munir, Zain.
Yes, ma'am. A.
A. Okay, three students are saying A. I think I should start doing a poll on this now. Munir, Zain, Abdul Rahman. Yes. Say something.
A, ma'am.
Munir is saying A. Oh, okay, looks like option A is winning. Unfortunately, option A is wrong.
But B, right?
Ma'am, C.
No, B.
C is also wrong. It will be B. Why?
Yeah,
Because,
because ma'am, in the third equation, if we substitute it, it will be plus 2.
okay. Okay, see, look at this, okay? I'm just trying to focus on this one. This one says, the option B, it says x plus y equals 0, right? So if you send y to the other side of the equation, it becomes x equals minus y. Yes or no? Getting it? I have just sent the y to the other side. It becomes x equals minus y. So x equals minus y means that the x coordinate and the y coordinate, they both have to be negative of each other. If x coordinate is -2, then y coordinate will be +2. If x coordinate is
Yeah.
2, then y coordinate will be -2. Is this clear? Why is
Yes.
it B? Okay, good. So now let's come to a very similar question, question number 12. Come to question number 12. Yes. The point of the form this, A minus A, always lies on which line? We just now discussed it.
X. No. Y is equal to x.
Y is equal to X. But you see, what do you mean when you say Y is equal to X? That means for every point, the Y coordinate will be equal to the X coordinate. The Y coordinate will be equal to the X coordinate. Are they equal? A and minus A? No. They are negative of
No.
each other.
Yeah.
So that means,
Ma'am, I guess B.
look, Y is equal to minus A is a line which is parallel to X axis.
Is it D?
Yes, it is D. See, Y is equal to
Oh, yeah.
minus A means that there is no restriction on X. X can be anything. But they are asking this point. See, it might lie on Y is equal to minus A. It might. But they're saying any such point, let's say 2 comma minus 2, 10 comma minus 10. All of these points, when you collect them, 1, comma minus 1, 2, comma minus 2, 3, comma minus 3. All of these points, when you collect them, you will see that they give you this line, x plus y equals 0. Why? Because over here, your x is your a, right? So a plus minus a is giving you 0, right?
Yes.
Look here, a plus, this is the x coordinate, a, and your y coordinate is minus a. So when you add them, you get 0, which is exactly what the last option says. Is that clear? Is that clear?
Yes, ma'am.
Okay.
Clear.
So now look, the 13th, 14th, and 15th questions. These are, you have to do them by yourself. Please. I am not going to repeat it, and I'm not going to accept it if any of you has not completed the homework. It's fine if you are not able to get the answer. It's fine if you have gotten an incorrect answer. It's totally fine. But you have to try. You have to try the question at least. In the next class, I want every single student to say, yes, I have completed the homework. Okay.
ma'am.
And I expect that all of you will send it to me on WhatsApp as well. Because these are important practice questions. If you don't practice, you will forget what you have learned. So
Oh,
now, if any of you hasn't received the questions, you can take a screenshot of these last 3 questions. And then we
ma'am,
will move on to the next chapter. Yes, Abdul Rahman.
uh, where are you sending that homework?
Sorry.
Okay, so,
Yes, Abdul Rahman, say.
so, where do we send the homework?
Send it on the place where you get the homework. The number from where you get the homework. You can say share it on the number where you get the link of the class as well.
Oh, where the class started, when you get
Yeah,
the class.
just any Learnivio's number, just send it and ask them to send it to me. Okay.
Okay.
Good. So, who all are there? Munir, Preshita.
Yes, ma'am. Yes, ma'am. There's some network issue. I was like, the voice was cracking.
Okay, no problem. I was just saying, ki please complete the homework and send it to me. Okay, that's all. Now let's go to the next chapter, which is the second one, which is polynomials. Okay. So just now we studied linear equations, polynomials, which we discussed in the previous class as well. Polynomials are, yes, does anyone remember what is a polynomial?
Ma'am, anything which has 5 numbers?
Not necessarily. See, polynomials, what we are studying in this standard in 9th grade is polynomials in one variable, okay? Whereas polynomials can be there in many variables. But polynomials are basically algebraic expressions, okay? Till now we were studying algebraic expressions. Now we will start calling them polynomials. And they can be of any degree, any power, which is a whole number, as we discussed in the previous class as well. So, for example, 5x square plus 3x plus 2. This is also a polynomial. Even though it doesn't have 5 terms, it doesn't have, its degree is not 5. Its degree is not more than 3, right? Its degree is what? 2. So this is a polynomial of degree 2. And this is called a polynomial in x. So we name this polynomial saying p of x. P of x. Let's say I have another polynomial g of x or g of, let's say, y. So it has to be, the variable has to be y. Okay, everything else will be considered as constant. So for example, if you have 3x cube minus 4x plus half. This is a polynomial in, oops, I was supposed to make it y. There you go. Okay, so this is a polynomial of degree 3 in the variable y. Okay. And we have, I believe we have done questions like this, that for example, root x plus 2. Is it a polynomial or not? Is it a polynomial or not?
No, no.
No, it's not a polynomial because here,
Because
the,
the power of x is not a whole number.
yes, the power of x is 1 by 2, which is not a whole number. So every single term in a polynomial should have the power as a whole number. Okay. For example, if you have 2x cubed plus 5 by x, is this a polynomial?
Yes.
Would anyone else like to say
No,
something?
no, no.
Why not?
Because the again the x is in the denominator.
So x is in the denominator means that this is x to the power minus 1. Do you remember what we studied in number
Yeah.
systems? That a to the
Yes.
power minus m is nothing but 1 by a to the power m. So since x over here was in the denominator, we sent it to the numerator and made that power. The power is actually negative 1, which is not a whole number again. So this is also
Yeah.
not a polynomial. Okay. How many terms can a polynomial have? A polynomial can have any number of terms. Okay. It doesn't just mean
Okay.
just one term or two or three or four. It can have any number of terms. So, acha, what is the degree of the polynomial 2x? This is a polynomial, right?
1.
Yes, the degree is 1.
1.
What is the degree of, because it's x to the power 1. What is the degree of the polynomial 5x plus, just a minute, 2x square by 3x? First of all, is this a polynomial or not?
No.
No, are you sure?
Oh, yes, yes, yes. It's a polynomial.
It is because when you simplify this or when you try to solve this expression, it becomes 5x by 3x plus 2x square by 3x. So you have to be very careful about when you're doing such questions, okay? So x and x gets cancelled. So this is 5 by 3 plus 2 by 3x. What is the degree of this polynomial?
1.
Degree is equal to 1. What is the degree of the polynomial 5? Is it a polynomial?
Yeah.
Yeah, it is. What is the degree?
Yeah. 0.
0. So because it is x to the power 0, and we said that the power can be anything, but it has to be a whole number. And here 0 is a whole number, right? So this 5, just 5 is called a constant polynomial, or any number. 1, -2, 1 by 2, root 3. This is called a constant polynomial because the power of 0, I'm sorry, the degree of x is 0. Okay.
Yeah.
Let's come to the exercise 2.1. Let's come to the exercise. Abdul Jabbar, you there?
Yes, ma'am.
Yes. Okay, let's come to the first question. Okay, Abdul Jabbar, which of the following expressions are polynomials in one variable and which are not? They are saying polynomials in one variable. So you have to be careful about the number of variables also. So you have to see two things. Number one, is it a polynomial or not? And number two, is it a polynomial in one variable? So the first part, 4x square minus 3x plus 7, Abdul Jabbar, that goes to you.
Yes, ma'am. Just taking a page.
page, I believe it is 29 in the new version of the book. If yours is the old version, then somewhere around 33 or something. Found it, Abdul Jabbar?
Yes, ma'am, it is a variable.
It is a polynomial in one variable. Okay. Number 2, y square plus root 2. Avni,
Yes, ma'am.
is it a polynomial in one variable?
No, it's not a polynomial
Why not? Reason?
because it has root 2.
What is the condition for it to be a polynomial? Let me write it over here, okay?
And it should be it should have one variable and yeah.
Polynomial in one variable, okay? Degree of each term should be not degree of each term, degree of variable in each term should be a whole number. Please note this down.
Okay, ma'am.
Riyaz, why were you absent in all the previous classes? Like the past 3-4 classes you were absent. Why? Riyaz, please
Ma'am,
message.
yes, ma'am. I was having fever.
Acha, okay.
Yes, ma'am.
Are you okay now?
Yes, ma'am.
Okay, good. All right, y square plus root 2. Now, Avni, look at this definition that I have just written over here. And now tell me, is y square plus root 2 a polynomial or not? If not, then why? Yes, Avni.
Ma'am, it is a polynomial.
It is a polynomial because this we look at the degree, we look at the power only of the variable, not of the constant. The constant can be anything. It can be
Yeah.
1.5, it can be -3, it can be -3/10 or -√3/10, anything. The constant can be anything, just the variable. The power of the variable should be a whole number. Okay, so this is also a polynomial in one variable. The third question, 3 root t plus t root 2. Abdul Jabbar. Okay, I think Abdul Jabbar has already done. Abdul Rahman.
Yes.
This one, third one.
Huh? Oh. Hmm. Is it-
Munir.
No, I can't solve it. Solve it.
Munir. Zen.
Yes, ma'am.
Yes, then the third one, is it a polynomial in one variable? Yes, then. Then is it a polynomial in one variable or not?
No.
The third one, I've written it over here. Yes, Avni.
Yes. Ma'am, it's not a polynomial
Reason?
because it doesn't have a degree and the degree is not a variable or a whole number.
See, over here, what is the degree of this term? T root 2?
1.
1.
No.
Because the power of t is 1. You have to look at the power of the variable only. So the power of t over here is what? 1. T to the power 1 is t, right? But over here
Yeah.
in the first term, what is the power of this term, degree of this term, 3 root t. What is the degree of this term? Yes, Avni?
Hmm. 1.
No, it is root t, right? So root t means t to the power half. We studied this in number systems wala chapter.
Okay.
So here, this can be written as 3 into t to the power half plus t to the power 1 root 2. We are
Yes.
only concerned with the variable. So we will just look at the variables. So this term, the second term is safe. It is fine. No issue with the second term. But the first term is an issue because t to the power half, whereas we said it should be a whole number. The power of this should be a whole number. It is half over here. So that is why this entire thing is not a polynomial. Did you get it now?
Yes.
Yes, I got it.
Okay. Now let's come to the fourth one. Abdul Jabbar. X to the power 10 plus y cubed plus t to the power 50.
Yeah.
Is it a polynomial in one variable or not?
No, ma'am.
What?
No.
Okay. Why?
Can I?
Yeah. Yes, Prishta.
Ma'am, it is a polynomial.
The question asks which of the following expressions are polynomials in one variable?
Oh, then it's not.
It's not. So see, this is a polynomial. Yes, it is a polynomial, but in one variable? No, it's not. It's not a polynomial in one variable. So you have to write the answer like this. No, it is not a polynomial in one variable. Okay. Next, the second question, let's come to that. Write the coefficient of x squared in each of the following. Coefficient is nothing but, for example, here, the coefficient of t is 3. Here, the coefficient of t is root 2. Let's say if I ask you the coefficient of x in 5xy, then you will say everything except x. So it will be 5y. The coefficient of x will be 5y. If I am asking you what is the coefficient of x in minus 2x squared, what will it be?
-2.
Okay, I'll repeat my question. Coefficient of x in minus 2x squared.
1.
This c minus 2x squared can be written as minus 2 into x, yes or no?
Yeah.
So here you have to leave x and think about everything else.
-2x.
Yes, minus 2x. So the coefficient of x in minus 2x squared is minus 2x. Okay. So
Yeah.
with that, let's come to the second question, first part. Coefficient of x squared in each of the following. 2 plus x squared plus x. Abdul Jabbar. Abdul Jabbar.
Yes, ma'am.
Yes. The coefficient of x squared in this.
1.
1. Very good. Because x squared is being multiplied with 1. And it's not written because we don't write 1 minute something is being multiplied, right? Then 2 minus x squared plus x cube. Avni?
-1.
-1. Very good. Then pi by 2 x squared plus x. What is the coefficient of x squared? Yes,
Can I?
then? Just a minute, Prishita.
Yeah.
Munir,
Yes, ma'am.
what is the coefficient of x squared in this term, in this polynomial? Pi by 2 x squared plus x. What is the coefficient of x squared in this? We shouldn't have to wait this long. It's a very simple question. Yes, Preshita.
Yes, ma'am. It's pi by 2.
So this is going to be pi by 2. The fourth one, root 2 x minus 1. What is the coefficient of x squared in this?
√2.
I'll repeat my question. What is the coefficient of x squared in this?
There's no x squared.
0.
There's no x squared, exactly. So you can write it as 0x squared, right? Yes, because 0 into x squared is 0 itself. So it doesn't make a difference. We're not changing anything. If we're just adding 0 to something, we're not changing anything. So that means the coefficient of x squared is 0. Coefficient of x squared is 0. Okay. Now let's come to the next question. Question number 3. Give one example each of a binomial of degree 35. So we need a binomial which has degree 35. Yes, Abdul Jabbar.
Ma'am, binomial is 4.
Binomial is?
And how much is
We discussed in the previous class. Monomial is that polynomial which has only one term. For example, 5x squared minus 3x, okay? Or just minus 7. A binomial is that which has just two terms. So like 2x plus 3,
ma'am,
x to
x
the power
raised to the
4
power
minus 9.
35. X,
Yes.
x raised to the power 35 plus y raised to the power 30.
No, we want the polynomial or a binomial in just one variable.
Ma'am, x raised to the power 35.
Plus something else. Let's say plus 3.
Y.
Yes. Plus 3. Or we can say plus 3x cube.
Yes,
The degree of this is again 35 only, na? Because we know that the degree is the highest power. So this is also an example. Got it?
Yeah.
Okay. Avni, can you give me an example of a monomial of degree 100?
No, 1 minute. Monomial, it will be x, x to the power 100.
Okay, you can say x to the power 100 or you can say 5x to the power 100. Okay, any of these will be fine. Okay, now let's come to the fourth question. Write the degree of each of the following polynomials. 5x cubed plus 4x square plus 7x. Preshita?
Yes, ma'am. It's 3.
3. The degree is 3.
Yeah.
4 minus y square. Abdul Rahman,
Yes.
degree of this polynomial.
Hmm.
Hurry
Uh,
up.
Not sure.
Why are you not sure? What were you doing all this time?
Okay.
Yes, Abdul Jabbar.
2, ma'am.
Yeah, the degree is 2. Abdul Rahman, you're going to get a serious complaint. Okay. Because you guys take this so lightly. A lot of you. 9th grade is not easy. Okay, let's come to the next one. What is the next one? 5t minus root 7. Agni?
Yes, ma'am.
Yes, this one. 5t minus root 7.
I have to say the degree.
Yes.
It will be 1, ma'am, because they didn't have a degree.
It doesn't have a degree. It does. And the degree is 1.
Yeah, ma'am, I said 1. I said
But
1.
you also said it doesn't have a degree. What does that
Yeah,
mean?
but I said 1 also.
Okay. So you have to be careful about what you're saying. Acha, why did you say it doesn't have a degree?
Because I thought 1 is not like, you
1
know.
is a whole number. And just
No,
because it isn't written, so you
yeah,
wanted to say it's not written over there. It's not visible. That's what you wanted to say?
yeah.
Okay. All right. Next. Three. Preshita,
Yes, ma'am. The degree is 0.
the degree is 0.
Yeah.
Okay.
For 3, how is a degree 0? And for 5t, how is it 1?
Okay. See here, it is, let's say, do you remember this? We were talking about this. Where did it go? Where did it go, bhai? Chalo, never mind. See, what we were talking about was, well, this 5t minus root 7. This has t to the power 1. Because you see, t to the power 1 is how much, Agni?
1.
Okay. Agni, what is 2 to the power 1?
2.
What is 3 to the power 1?
3.
What is t to the power 1?
T.
What is x to the power 1?
X.
Okay. Remember this. All right. Now, what is x to the power 0?
X.
X to the power 0 is also x.
0.
No. Remember, we studied in number systems. A to the power 0 is equal to 1, no matter what a is.
Ah, yes, yes.
Yes. So, x to the power 0 is 1. So, 3 over here, there is an invisible 1, right? Next to any number, it is always being multiplied with an invisible 1. 1. So, it is being multiplied with a 1. Now, this 1 can be written as, because we know that 1 is equal to x to the power 0. So, this 1 that we wrote over here can be written as x to the power 0. Yes. So, that is why the degree of this is 0.
Okay, ma'am, got it.
Classify the following as linear, quadratic, and cubic polynomials. So all of you just take 2 minutes to do this, and then I will ask randomly. Abdul Rahman,
Yes.
please do the 5th question, and I will ask, and you will also be asked about the 5th question. Okay, please do it.
What is the fifth question?
Do you have the textbook with you?
Oh, yeah.
Do you know which chapter we are doing, Abdul Rahman? Yes, Abdul Rahman, do you know?
Yes.
Yes, which chapter are we doing?
We're doing chapter 7.
Chapter?
7.
We're doing chapter 7. What's the name of the chapter?
No, I just remember the chapters numbers.
Okay, continue whatever it is you were doing. I won't disturb you.
Done.
Good, okay, fine. So, chalo,
Can you
okay.
share the questions? I don't have the textbook with me, and if I'm searching online, the textbook is not downloading to my laptop.
Acha, fine, wait. Share screen. This one.
Okay, ma'am.
So you have to classify it as linear, quadratic, or cubic. So, Abdul Jabbar, first one,
Yes, man, and it's quadratic.
quadratic. Reshita, second one,
Ma'am,
Cubic.
cubic. Avni, third one.
ma'am, linear.
Third one is linear. What is the highest power, or what is the highest degree in the third one?
Oh no, ma'am, quadratic.
Quadratic. Again, your cameras are off. Switch them on. Zen,
Yes, ma'am.
fourth one, is it linear, quadratic, or cubic?
Linear.
Linear. Then Abdul Jabbar, fifth one,
Linear.
linear. Preshita, sixth one,
Quadratic.
quadratic. And Avni, last one,
Ma'am, quadratic.
last one. Look at it carefully.
Cubic, ma'am, cubic.
Cubic. Okay. All right. Done. Fine. Now let's see what is zero of a polynomial. Do you remember in the previous chapter when we were doing linear equations in two variables, there was a graph that we saw on the graphing calculator, and the graph of that, it went something like this, and the calculator was saying this point to be root. Do you remember this? Does anyone remember?
Hmm.
Ma'am,
Yeah, it was
yes.
saying that this point is root, and this point it was saying as y-intercept. Okay, forget about the
Yes.
y-intercept. We don't need that in this chapter. But root is exactly what zero of a polynomial means. See, over here, this was a linear equation or linear polynomial. Okay, this was linear. But in case of your higher degree
Okay.
polynomials,
I remember the chapter. Uh, I remember the name is called triangle.
yeah,
Correct?
So in higher degree polynomials, you're not going to get a straight line when you draw the polynomial on the graph. What are you going to get? Does anyone know? Does anyone have an idea of what will happen if you plot a quadratic polynomial on the graph? What
We'll
will
get
happen?
0.
No, what shape will you get? That's what I'm asking. So when you plotted a linear one, you got the shape as a straight line, right?
Yeah.
When you plot a quadratic one, what shape are you going to get? When you plot a cubic polynomial, what shape are you going to get?
Wavy.
Yes, Avni?
Quadratic will give wavy.
Actually, cubic will give wavy, but quadratic will give something that I don't know if you guys have heard of it. Have you heard of a parabola?
No.
No? Okay. So a quadratic is going to give that shape. If you want, you can try it out. Okay. A quadratic is going to give that shape, and the shape looks like this basically. So if this is your graph, the x-axis and y-axis, then your parabola is going to look like something like this. Okay. Sorry. That is the
I'm
shape of
like
a
sound
parabola.
waves.
Not exactly like sound waves. See, your sound waves are a bit different shape, but you can't exactly call them sound waves. See, for example, now you said wavy, right? So cubic will look like this. This is what cubic will look like. This is
Yeah.
a parabola, which is for quadratic, and this is cubic. Okay. So anyway, so why are we talking about this? Because we were discussing the concept of root. Root in terms of when we saw in the previous chapter, linear equations and two variables, root over there meant for what value of x is y going to be 0. I'm going to repeat this, listen carefully. Root was for that value of x, for which y becomes 0. That is your root, right? When we're talking about polynomials, it's almost the same thing. Root of, or 0, we also call it 0 of a polynomial, is that value of x, or the variable, if you're talking about some other variable, that value of x for which p of x becomes 0. Very similar to what we did in the previous chapter. That value of x for which p of x becomes 0. So let's see what does it mean to
I
have
didn't
a
get
0 of a
this
polynomial.
statement.
You didn't get the statement of this? Okay, did you get this one?
Yeah, I got that one.
You got that? The same thing, just replace y with p of x, because over there we had x plus something, y is equal to something, right? We had x also and y also. Here we don't have y. Here when you plot a graph, you will not say that the y-axis is y-axis. You will say this is p of x. Don't get confused or anything. It's just that value of x for which over here we said that value of x for which y becomes 0. But now when it comes to polynomials, since we don't have a y in the picture, we have a p of x. So we're saying that value of x for which p of x becomes 0. Okay, let me show you. Okay, just a minute. Where did my Zoom go? Just a minute, I'm sharing my screen. Can you see my screen? The
Yes, ma'am.
calculator? Okay. So can you name a quadratic polynomial? Anyone? Name a quadratic polynomial.
2x square.
2x square. Okay, fine. 2x squared. That's a parabola. Okay. Can you tell me where is, for which point or for which value of x, is the value of y-axis 0? See, over here it's written f of x. Can you see on the left hand side of
Yeah.
the screen? Right? F of x, because it is a polynomial. And when you reach higher grades, and if you want to do math in 11th grade, you will come to know that this f of x is called a function of x. Okay, which is not very different from polynomials, but don't get into all that. It's just that for what value of x is this p of x or f of x 0?
0.
Can you exactly for 0? If you want, you can just apply that over here also. See, for what value of x is f of x 0? So you want your f of x to be 0, right? So you want your f of x to be 0. What is your f of x according to this equation?
2x square.
2x square. So your 2x square is 0. That means your x square is 0 divided by 2, which is again 0. That means if x square is 0, then what is x?
0.
0.
X is 0. So do you see, what we have done here is we have found the 0 of the polynomial, or in other words, the root of the polynomial, which we know that from the graph also we can see that it is 0. For what value of x will y be 0? Or f of x in this case be 0. Is this clear?
Yes, ma'am, clear.
Okay. So we're going to take, just give me another example. Let's say x squared plus 5. Where did it go? Where's my x squared plus 5? Oh, there it is. Sorry, I should say minus 5, so that it's no. Also fine. Y squared plus 5. Oh. Acha, fine. X squared minus 4. Thank God. Okay. So look at this. What does it say this point is? This point is the
2.
root 2
2,
comma 0. So what for what value of x is the y coordinate 0?
Yes, ma'am.
For what value of x is the y coordinate becoming 0?
2.
2. But over here also, see? Over here also it's becoming 2. So how many roots are there?
2 roots.
2 roots. So you will study this in your 10th grade. I'm just gonna name it over here. You don't have to remember it. The number of roots of any polynomial is equal to the number of the degree of that polynomial. So do you remember our line, our linear equation? The line had only one root, right? Was it possible for the line to have more than one root? No. It is going to cut the x-axis at only one point because it was a linear equation. Here we have quadratic equation. So this one has 2 roots. When you have a cubic equation, you're going to have 3 roots. It's going to be like that. Okay?
Okay.
Yeah. So anyway, so
Can
that
you do
is,
one for cubic?
yes, Avni?
Can you do a graph for cubic also?
Sure. Where did my this thing go? Expression. Why isn't it coming? Where did the keyboard go? Bhai? Acha, okay, here. Cubic. So let's say Mm-hmm. X. Okay, no, I'm going to clear this. Fine. X cubed plus 2x squared plus 2x, I guess. I'm just making a random this thing. Minus, okay, this is not going to help. This should be 4x, I think. Nope, just x. Yeah, better. Can you see the red line? Can you see how it's wavy?
Yes.
Yeah, that is a cubic equation. And over here, you can see it
That
has
means it has a
only
lot of zeros, right?
a
These are all
cubic.
zeros of.
Sorry, can you repeat?
These are all zeros of this for this.
What all are zeros for this red graph? Look, this one is a 0. Root, it says root minus 1 comma 0. So for minus 1, the value of y is 0. And over here, the origin is also the root. Okay, 0 comma 0. The third root is also there, but we cannot see it because of something called complex numbers, which you'll study in 11th grade. So the roots that we can see are 2 over here. Okay.
Yes.
Yeah.
Fine. Let me just give you a very easy example of this x cube. Okay, Avni, that is your very simple cubic equation, cubic polynomial, which is x cube and nothing else. And
Okay.
what is the root of this? Only one root, which is 0 comma 0. Because we can see that, right? It is pretty obvious that 0 cube is equal to 0. If you want the value of p of x to be 0, then we know that 0 to the power 3 is 0. So that is why the value of x is coming out to be 0. Is this clear?
Ma'am, clear.
Okay. Just a minute. There's someone on the door. Okay, so that is an introduction to the roots topic. We can have, we will continue this class. We will continue this in the next class, okay? So today I am letting you guys off 15 minutes early. I think you might have a test right now. Just a minute, let me just check. Wait a minute. Yeah. Okay, you will have a test. Any doubts?
Ma'am, which test?
There will be just a test which happens right after the chapter.
Oh, okay.
Not right now.
Okay. Yeah, right now, I think. Or
No.
if they are not contacting you about it, then maybe you can leave. You can just leave the class.
No, I have to quit.
Chalo, okay, fine. You may leave the class.
Okay.
Okay.